Hello world, today we're going to be talking about binomial distribution. So binomial distribution. Okay, so basically this is the first point that we're going to make today. This is a distribution resulting from the outcome of a binomial experiment. Okay, obviously your question there is what is a binomial experiment, but that will be answered shortly. A binomial experiment usually involves several repetitions so these repetitions let's call them trials of the basic experiment. You know, experimental probability, right? We also need to take note that the binomial probability distribution gives us the probability that a success that a success a success will occur X times in N trials. A success will occur X times in N trials. For X will take values from 0, 1, 2, 3 up to N. So this probability will give us the probability that a success will occur X times in all these number of trials. So it is telling us that a success will occur maybe 3 times, or it can occur N times in these trials. Now let's look at the characteristics of a binomial distribution. So now we're going to be talking about characteristics. What makes you know that this is a binomial distribution? The experiment must consist of N identical trials. That's one. And two, each trial is one of the two possible outcomes and these outcomes are basically success or failure. Okay, I'm gonna write a rub off there. Success or failure. You need to take note that success is the desired outcome. Okay, so the next one we're going to have the point that we're going to have there, another characteristic. The probability pi that the trial results in success remains the same from trial to trial, from trial to trial. Okay, so if they say the probability of success is 10%, it will always be 10% from each trial to the next. And then another important point is that the trials are independent of each other. The trials are independent of each other. Okay, so what does that mean? The outcome of one trial does not affect the next. Now let's write the probability distribution. Okay, let me just erase here and then write the binomial probability distribution is given by probability of x is equal to n factorial over x factorial open bracket n minus x factorial out there, and then all this is going to be multiplied by probability of success to the power of x 1 minus probability of success to the power number of trials minus required number of trials, like that. Okay, now that's the binomial distribution. And then we're going to write what each term stands for in that distribution, and we are saying n is equal to the number of trials. Or we can term this sample size. And then pi is going to be probability of success on each trial. And then x, that's the binomial value from 0, 1, 2 up to n. And then this sign here, you might need to write it down. It means factorial of positive integers of n. For example, if we say 4 factorial, this is equal to 4 times 3 times 2 times 1, which is equal to 4 times 3, that's 12, times 2, that's 24, times 1, that's 24. Okay, and if we say 5 factorial, it also means 5 times 4 times 3 times 2 times 1, which is equal to that's 20 times 3, that's 60, times 2, that's 120, times 1, that's 120. So 120. But take note, 0 factorial is equal to 1. That's an important result there. You should always know. Okay, so that's basically an explanation of each and every key term in the binomial probability distribution. Right. Now, let's right away look at the mean. Mean of a binomial distribution. So mean is equal to sample size basically n multiplied by probability of success, which is pi as previously mentioned. So mean is equal to n times pi, like that. And then so that's our mean, which is mu or expectation of x, like that. So mean, which is expectation of x, is equal to n times pi, like that. Now let's talk about the variance. And standard deviation, let's just call it ST, of a binomial distribution. Okay, so this one is given by sigma, that's standard deviation, which is equal to root of sigma squared, which is root of your variance. We know this, that standard deviation is always root of variance. Okay, and this is root of n, which is number of trials, times pi, which is probability of success, times 1 minus pi, which is effectively probability of failure. And then if you root this, you get the standard deviation, which means if it is not rooted, you are getting the variance. Okay, so with that background to binomial distribution, let's right away jump into a question so that we put this into practice and you can be able to see this clearly how it applies. So we have a question here where they're saying a drug is known. Okay, let me write it here as well. A drug is known to be 80% effective in curing a certain disease. If 4 people with the disease are to be given the drug, find A, the probability that more than 2 are cured. B, exactly 4 are cured. C, no one is cured. D, the expected value of people cured. And E, we're gonna look for the variance. Okay, so for us to do this, we have to take note of important things here. Now, the first thing you have to identify is your probability of success. And in this case, 80%, a drug is known to be 80% effective in curing a certain disease. So 80% of the people are going to be cured if this drug is administered. So we will term this the probability of success. So 80% of 0.80 is the wanted situation because we want to get more people cured. We also have our N, which is equal to if 4 people with the disease are to be given the drug. So the number of people in the experiment in our sample is 4. So we are only going to take 4 people. So these are very important values. Now we also need to remind each other of our probability distribution. We said Px is equal to where is it where we wrote it? Okay, there it is. N factorial over that. Okay, so we're gonna write it here. N factorial over x factorial n minus x factorial times pi to the power of x 1 minus pi to the power of n minus x. Okay, so now we need to apply even all the other rules that we've learned in probability so far to answer the questions with all those things in mind as well. The probability that more than 2 people are cured. So for A, we are saying probability that x, which is the number of people cured, is greater than 2. Right. So this one, it means we are not going to include 2. We're going to start from 3 and 4. This is basically probability of having 3 people cured plus probability of having 4 people cured. Now, take note, we are ending at 4 because our experiment only goes up to 4 people. Right. Now, with that, we apply our probability formula to find what is Px equal to 3 and what is Px equal to 4. So we're going to apply these values into this. So, instead of writing n, we're going to write our n is 4, we know that, so 4 factorial over our x. In the first case, our x is 3, so 3 factorial n minus x, that's our 4 minus 3 cross bracket factorial. Now pi, our pi, that is our probability of success, which is 0.80 to the power x. Our x in the first case is 3 times 1 minus pi, that is going to be 1 minus 0.8. It's going to give us 0.2, but anyway, for now we will just write it like that. So n minus x, that's 4 minus 3, like that. And then to that we add the next one. So again, we're going to apply this probability formula here. So we're going to say n, our n is 4, it doesn't change, factorial, over our x has changed now because we are saying px equal to 4. So basically we are now looking for the probability of 4. So wherever there is x, we're going to replace with 4. So we're going to have 4 factorial out there, and then in brackets 4 for n, because 4 samples, minus x, our x is now 4, and then we find the factorial of that. Now times pi, our probability of success doesn't change from one trial to the next, so it will still remain 0.8 to the power of x. In this case, x is now 4 multiplied by 1 minus 0.8 to the power of 4 minus 4, because n is 4 and x is 4. Now we have to weight that with our calculator. So 4 factorial, we are saying this is 4 times 3 times 2 times 1, and if you work it out, you get 24 over 3 factorial, that's 3 times 2, that's 6 times 1, that still remains 6, so we have 6 there. 1 factorial, that's 1, right? So we have 1 there, and then 0.8 to the power 3, that's going to give us 0.8 to the power 3 is going to give us 0.512, so times 0.512 times 0.2 to the power 1, so this one will be 0.2, right? Because we are saying 0.2 because I've already subtracted 1 minus 0.8, which is 0.2, and then the indexes here are saying 4 minus 3, that's 1, so 0.2 to the power 1, it will just remain 0.2. Okay, so we have that there, and then we go to the next one. 4 factorial is going to give us 24 there, and then 4 factorial, that's 24, and then 4 minus 4, that's 0 factorial, it will give us 1. Okay, and then 0.8 to the power 3, that's 0.8 to the power 4, sorry, to the power of 0.8 to the power 4. That's going to give us 0.409, and then 1 minus 0.8, that's 0.2 to the power 4 minus 4, it will give us 1. Any number raised to the power of 0 is 1. Okay, so with that in mind, we can now work the solution out right away by just putting all those values into the calculator. So we are saying 24 times 0.512 times 0.2 divided by 6. So in the first case we have 0.4096, right? And in the second case we're going to have 24 divided by 24. Okay, I don't know what my Skype is trying to do to us there, but anyway, never mind it. So 24 divided by 24, that's 1 times 0.4096 times 1, so it will give us 0.4096 again. Okay, so we have 0.4096 in both cases, and then we add those two. Our answer will be 0.812. Okay, 0.8192 there. So there's a 9 there, 0.8192. Okay, now we go to the next question, exactly 4 cured. Okay, so B says exactly 4, so px is equal to 4, right? Px is equal to 4. That's exactly similar to this one that we have done, this only this part, right? Only this part. So we're just gonna write, why am I saying only this part? We could take it into to our equation so that we don't confuse the two. So we are saying px equal to 4, but our distribution is n factorial over x factorial n minus x pi to the power x 1 minus pi n minus x. So if we substitute again all these values into here, we have, for n, we know our n doesn't change, it's 4, so we're saying 4 factorial over our x is 4, so 4 factorial, n, that's 4 minus 4 factorial, and then okay, here on writing the formula I messed up here. Okay, so I'll write x there, and my factorial is supposed to be outside. That's the only problem. And then 4 minus 4 factorial on this one, and then we now substituting for pi. That's our probability of success, which is 0.8 to the power of x, which is 4, open bracket 1 minus 0.8 to the power of 4 minus 4, which is entirely this that I had already highlighted. So what we're gonna have from there is basically this again, this next one, this one, because 4 factorial is just gonna give us 24 over this one is 24, 4 minus 4, that's 0 factorial, which is 1, so that's 24 times 1, and then 0.8 to the power 4.8 to the power 4 is gonna give us 0.4096, so this times 0.4096, and then this one 0.2 to the power 0, that's 1. So the final answer will be 0.4096. Okay, so that's it for that one. The next one that we're gonna do is they said find the probability that no one is cured. Probability that no one is cured. So that's probability of curing 0 people. Px is equal to 0. That's the one that we're gonna be looking for. So it's exactly the same situation. We're gonna use this distribution here. So we're gonna say n factorial over x factorial n minus x, like that, and then pi x. Okay, the reason why I always write my formula always is most examination boards want you to state the formula every time you are answering a question. It doesn't necessarily mean that if you have written it in the previous question, you don't have to write it again. You have to keep on writing it, and that way, even in your practice, is how it sticks to your head. Okay, so n is 4 always, so 4 factorial. X in this case is 0, so 0 factorial, and then n now is 4, it doesn't change, minus x, which is 0, and then I put my factorial there. Probability of success, that's 0.8 to the power of x, which is 0, 1 minus pi, which is 0.8, it doesn't change from trial to trial, we said. Okay, n is 4 minus x, which is 0 in this case. So we're going to put that into our calculator. 4 factorial is going to give us 24 over 0 factorial, that's 1, and then this one is 24 again. 0.8 to the power 0, that's 0, and then 0.2 to the power of 4. That's gonna give us times 0.0016. Right, now with that we multiply by 24 over that, which is basically 1. So our answer is going to still remain 0.0016. So the chance that no one is going to be cured is this low. Yes. So that's it. That's our C, part C of the question. Now let's go to the next one, which they are saying the expected value of people cured. Now that one is our expectation, and we said expectation is mu, which is equal to expectation of x, which is equal to number of people cured times the desired outcome, like that. Now number of samples, sorry, n is number of samples, is 4. The desired outcome is 0.8. So the expectation there is 4 times 0.8, which is equal to 3.2. That's it for our expectation. So that's the D of our question. And then we go to E of the question. Right. On E they're saying find the variance, I think. Yes, the variance. And we already said the formula for variance is given as that. So variance variance of x is equal to pi times n times 1 minus pi, like that. Now is the variance, so we are not going to find the root like in the previous case. So now pi, the probability of success is 0.8, n is 4, and then 1 minus pi, that's going to be 1 minus 0.2, which is going to give us 0.8 times 4 times 0.2, 0.64. So we have come to the end of this question. Let's just for interest's sake, maybe do another question, just to make us more, deep in this. Okay, so what question are we gonna do here? Okay, I got one here. So I'm just gonna write it here again. Example 2. Bank robbers brandish firearms to threaten their victims. In 90% of the incidents. An announcement that six bank robberies are taking place is being broadcast. Find A, the probability that a firearm is being used in at least one of the robberies. B, find the expected value. And C, the standard deviation. Right. So, to answer that, for A, we are saying probability that, okay, before we even get there, we need to take note of important things, which are our pi, which is probability of success in this case. That is the probability that an armed robbery is taking place, is 90%, 0.9. N is going to be number of symbols taken, 6. Right. Now we can start answering the question. The probability that a firearm is being used in at least one of the robberies. So A, for A, probability that at least a firearm is being used, so Px is greater or equal to 1. They are using at least a firearm, that is 1. Okay, and now this is the same as 1 minus the probability of x being less than 1, like that. So we can say 1 minus probability of x being less than 1, there's only one discrete value left, which is 0. Okay, so probability of 0, 1 minus px equal to 0, will give us this probability. We could have calculated this as px equal to 1, because 1 is included, plus px equal to 2, plus px equal to 3, plus px equal to 4, plus px equal to 5, plus px equal to 6. Right. So basically, in other words, we are taking all the other probabilities and leaving 0 out. So that's basically 1 minus this. Remember, probabilities always add up to 1. So with that, we can also say probability of success plus probability of failure is equal to 1. So now we have this. We can now use our px is equal to n factorial over x factorial n minus x factorial pi to the power x multiplied by 1 minus pi n minus x, like that. Okay, for this value, and then we'll subtract the answer from 0. So n remains 6 in this case over x. Our x is 0 factorial 6 minus 0, and then you say factorial pi is going to be 0.9, so 0.9 to the power x, which is 0. 1 minus 0.9 n, which is 6, minus pi x, which is 0, and then that from 1. Okay, so which is just to say 6 factorial. Okay, where is factorial on my calculator here? Okay, I can't see it, so I'll say 6 times 5 times 4 times 3 times 2 times 1, and then I'll get 720. So this is 1 minus 720 over 0 factorial is 1 multiplied by 6 minus 0, that's 6. 6 factorial, that's 720 times 0.9 to the power 0, that's 1, and then 1 minus 0.9 to the power 6, so that's 0.1 to the power 6. Okay, and that is going to give me 0.0000001. Okay, so I'll multiply that answer by 1, I'll multiply it by another 1 because 720 over 720, and then I'll subtract it from 1 to get 0.999999. So the probability that a firearm is being used in at least one of the robberies is 0.99999. Okay, so with that, we've come to the end of binomial distribution. Let's meet again in our next video as we explore other concepts. Thank you.